This is my introduction demonstrating the effect that momentum has when playing the game of tennis. The reasoning I have behind my choice to focus on tennis as my topic is because tennis is an active part of my life, and I thought that analyzing the different aspects of the sport may help me to further advance my game and skill while studying the science behind it. Tennis will be related to momentum as it clearly demonstrates the need for precision of time, velocity, and force. Now, in this part of my video, I will be demonstrating some good examples of how a backhand and forehand shall be properly swung. While showing momentum, the mass is in motion, which is the tennis ball, and the tennis ball is 0.0585 kilograms. And the velocity is the speed of the ball of which it travels after hitting my racket head. For my first good example, I found my momentum using the equation P equals m times v. My mass was 0.0585 kilograms, which was equivalent to that of one tennis ball. For my first velocity, which was my outgoing velocity, it was the speed I create when hitting the ball. When figuring out my velocity, I used v equals d divided by t. Velocity equals distance divided by time. My distance was 21 meters, and my time was 2 meters per second, which gave me a final velocity of 10.5 meters per second. Then I multiplied my mass and velocity and got my first answer of 0.61 kilograms meters per second. My second momentum, while figuring out now the incoming velocity, I used the same equation, P equals m times v. My mass remained the same, which was 0.0585 kilograms, although my velocity changed, though by still using the velocity formula, v equals d divided by t, my distance was now 24 meters, which was divided by 60 meters per second, which then gave me an answer for the velocity of 0.4 meters per second. Then I multiplied my mass, 0.0585 kilograms, times my velocity, which is now my incoming velocity, which was 0.4 meters per second, and I got an answer of 0.0234 kilograms meters per second. The incoming velocity is the speed of when the ball machine is feeding me the tennis balls. Now, to determine my second momentum, I had to add up my momentum from my first equation using the outgoing velocity plus my incoming velocity equation. So I added 0.61 kilograms meters per second plus 0.234 kilograms meters per second and got my second momentum of 0.63 kilograms meters per second. Some good techniques as shown with my forehand and backhand strokes is that my stance is well maintained with my legs shoulder width apart. I'm split stepping before the ball, which means I am jumping and spreading my legs apart to load and reload to generate more momentum before each stroke to release the maximum speed and force. And also, my timing is accurate and allows for great contact point with the ball, which means each time before a new stroke, I am bringing my arm back in a loop-shaped form to make accurate contact point with the ball before each follow-through shot. When looking at the force of tennis, it is created by my racket at its point of contact with the tennis ball. To find my first impulse and force of my first example showing good technique, I used the answer I got from my first momentum equation, which was 0.63 kilograms meters per second as the mass. To find my time, I checked at which my racket was making direct contact with the tennis ball, which was 0.4 seconds, the amount of time of how long it was. Then I divided 0.63 kilograms meters per second divided by 0.4 seconds, and I got a force of 1.6 newtons. Now, here is a bad example of how a forehand stroke and backhand shall not be hit. Now, When figuring out my momentum showing bad technique, I use the same equation as before, P equals m times v, with my mass being the same, 0.0585 kilograms. To find my first outgoing velocity, use equation v equals d over t. My distance here was 13 meters divided by 2 seconds, which gave me a velocity of 6.5 meters per second. When multiplied with the mass, I got 0.38 grams meters per second. When finding the second momentum showing bad technique, I use the same equation, P equals m times v. My mass was 0.0585 kilograms, and my incoming velocity was found by the equation v equals d over t. My distance was 18 meters, and my time was 50 seconds. After dividing those two, I got 0.36 meters per second. To get my final momentum, I'd added up the momentum from the previous bad technique and the momentum from this one, and I got 0.40 kilograms meters per second by adding up 0.38 kilograms meters per second and 0.021 kilograms meters per second. To find my second impulse and force of my video showing bad technique, I used the mass from my answer of the momentum equation when I was showing also bad technique, which was 0.40 kilograms meters per second. And I got my time of 0.32 seconds at which my racket was making contact with the ball. Then dividing 0.40 divided by 0.32, I got my force of 1.25 newtons. This is my conclusion of my video analysis showing the momentum through the game of tennis. When focusing on collision elasticity, a tennis racket's strings are very elastic and will exert a strong force on the ball when it impacts the strings, which helps to add to the impulse which is delivered by the tennis ball when it is hit by the racket. This is seen when the ball bounces on a tennis court. After viewing my video and getting some insight on the game of tennis, it is easy to pick out some of the good and bad techniques as shown and performed by myself. When taking the factor of time into consideration when playing tennis, it is important when showing a good technique to have a fast time, which adds more force and momentum to your shots, whereas when you swing slower at the ball, the force is less along with the impulse. To help improve some bad techniques of playing tennis, you should try to make direct contact with the ball, follow through with all strokes, avoid having the wrong grip, do not stand straight, and try to get down low under the ball to add more topspin.